How do you create a series of numbers? Say it can be increments of 1, increments of 2, etc. So here we're interested in creating a series, number series from 0 up to 360. So let me first start with 0 here, okay? And then I go to the fill function in Excel. You can find it under the Home tab. And then under Editing, you have this icon here, Fill. You click this, and then you have this series. Series. And do you want the series to be in rows? If it's in rows, then it will record the numbers going this way. If it's in columns, then it will record the number going down. So we're interested in generating a series in a column. So there you can have types here: linear, growth, even date. Okay. If you press date here, it will ask you, is it daily, weekday, etc. For now, it's a linear type that we want. And then, okay, you can click this one, trend. Okay, stop value. Okay, but a trend is for, it will determine the slope first. Okay, so the step value means what will be the increment? How much will each step increase? You can put here in tens, in hundreds. We're just interested in one, and then we want it to stop up to 360 there. So okay, all right then. That's an easier way, especially if you have a long series. Okay, it will be quite unwieldy to click and drag your series. Okay, did you get it, class? May I have your confirmation if you got the trick, or any questions? Okay, good, good. All right, thank you. Thank you for your feedback. Okay, so let's now fill up our amortization table. Month 1 is supposed to be the month that we're going to receive the loan. So there will be no interest yet, okay? No reduction in principal. And the month-end principal at the end of the beginning of the month, 0th month, the principal will be 2.7 there. This is what we owe. All right. Then on the first month, okay, your loan of 2.7 million would have already incurred interest. Okay? It would have already incurred interest. So how much are we going to pay? Maybe let's give this a name. Okay? Let's give this a name. Let's call it let's call it Amort. Amort amount. Or anyway, any name you want. Amortization amount. Okay? So amortization amount, then if you want, we can include here, maybe let's include here the interest per period. Okay? So our interest per period is equal to 975 divided by 12. Okay, so that's 0.008. You can make it as percent. Okay. And let's give this a name also. Let's call this int per period. Okay. I'm just thinking of a name. Okay. Okay, because we said that these are absolutes, and we can make use of this. Okay. So what will be the interest, class? What will be the interest? How do you compute for the interest? the interest will be equal to whatever was the ending balance, whatever is the balance, the principal balance, you multiply that by the interest per period, this one. Okay, so the balance multiplied by the interest per period, you get 21,937. Okay, so which means that for the first month, the amount that you're paying, 23,197.17, okay, this will be 21,000 of that will be interest. Only the balance less than 1,000, less than 2,000 will be a reduction in your principal. Okay, so this will be equal to our monthly amortization, okay, minus the interest. Control Enter. Okay, so only around 1,200 will be reduced or subtracted from your month-end principal. So this will be equal to how much will be the balance of your loan? This amount minus whatever was deducted from your principal. There. Okay, let me pause for a while, and I'd like to ask you to give you time to digest this and give you time also in case you have questions. And I have your confirmation if you got it. How did we get? Okay, thank you, Nix. Okay, so let me repeat the process. Okay. Okay, so let me erase this. Okay, let's do the process again. You have to know how to compute the interest. The interest is equal to how much was the balance. So this is the balance, right? This is what we own, what we loaned, and we haven't paid anything, any of this. So the monthly amortization will be proportion to your interest and your principal. So some of this will be interest payments. Some of this will be for the principal, which means your principal will decrease. Okay, so when your principal decreases, your interest will decrease. So each step of the way, your interest will keep on going down because your month-end principal, okay, your month-end principal will decrease. And your principal payment now will keep on increasing also. When your interest goes down, your principal payment goes up because your monthly amortization is fixed, it's constant. So let's show this. So this is equal to whatever was the balance last period, multiplied that by the interest. Did I use INT? There. Interest per period. There. Interest per period, Control Enter. We got this. So take note of the 23,000 we're going to pay for month 1, 21,000 will just go to interest. Okay. And then, so how much will be left for principal? It's your monthly amortization, okay, minus what will accrue for the interest. Okay, Control Enter. There. Okay, did that answer your question, Nix? Okay, good. How about the others? Okay, let me just finish this. Okay, so this will be equal to the 2.7 million minus the principal payment. So we still owe Pag-ibig 2.698 million because only 1,259 was removed from the removed from the principal. Okay, so let's continue this. Okay, so for month 2, what will be the interest? The interest will be equal to the previous month end balance multiplied by, once again, the interest. Okay, interest per period. Okay, 21,927. Still a big chunk. Okay, a big chunk of what you're going to pay, 23,197, will be interest payments. Okay, but notice that interest payment went down. Not 21,937, it went down by 10 pesos. Okay. Why? Because the month-end principal went down. Okay, so the interest will also go down. Okay, so your principal payment now will be your monthly amortization minus the interest payment. Okay, so what's left of your payment is for the principal, and your principal payment went up because your interest went down. Take note that this amount, the 23,197, will either go to interest payment or reduction in principal. Okay, so what will now happen to your principal? It will be this amount minus, okay, the ending balance of your principal minus whatever you pay to the principal. Okay, so once again, it went down by just 1,000. Okay, so let me pause for a while and ask you, is this clear so far, class? Okay, good. How about the others? Okay, good. All right, that's good. Okay. Now, actually, we don't need, of course, we're not going to do this per month, because you notice that this one will month 3 be the same formula. It will be equal to the previous month end principal balance multiplied by the interest per period. The interest for month 3, will it be the same formula? If we just copy down, so this one will go down also. F15 will become F16. And we will multiply it with the interest per period. Okay. Will the process be, will just keep on repeating? Will it be iterative? Okay, yes. Yes, that's correct. Yes. So what we can do is, okay, okay. After month 1, this formula will be the same for month 2. It will be the ending balance. Okay. How about the principal? The principal will also be equal to the amount amortization minus the interest. Okay. And the principal balance will still be whatever the previous one is minus the principal reduction. Okay. So what we can do now is highlight this and then copy this down. Or we can just, I'll go here. You can see the crosshair here. Okay, and then click this there. So it automatically runs the up to 360. Okay, so what do you notice about this? If we plot the interest, okay, so let's plot this, insert, and then let's do this one. Okay, you notice that the interest is going down, right? While on the other hand, so let's, okay, let me pause for a while. Were you able to plot class the interest? Okay, good. Dragon Town. Okay, sige. There's a question here. Okay. Okay. So let me remove, okay, maybe Control Z. Okay. All right. So this is our model again. Okay. The interest formula is the month-end principal multiplied by the interest per period. So this formula will be the same formula here in month 2. Because if we copy the formula down, then the month-end principal will also go down here. Okay, and the interest per period is just is fixed. Same thing for the principal, which will always be how much is the monthly amortization minus whatever was paid to the principal. And also for the month-end principal, which is just the previous monthly balance minus the principal payment. So these formulas are the same as the next ones. So what we can do is highlight this because we're going to copy it down and go to that lower right portion. You'll see here a cross here. This one, the cross. I hope you can see that black cross there. And then double click that. So it will now copy the formulas below. Okay, Sam, were you able to get it?
Sorry, sir. What's the formula for the principal? It's amortization amount.
This one, this one. Excuse me. Okay, so this one,
Yes, sir.
it's equal to this monthly amortization. This is a fixed amount that we're going to pay, and then subtract the interest. Okay, because as we know, the logic here is this: the 23,100, the 23,000, okay, will be allocated to interest and principal. So if I pay here, if I pay here 20,000 interest, therefore only 3,000 will go to principal payment. If I pay here 10,000 for interest, therefore 13,000 will go to principal payment. So this sum will always be 23,000, 23,197. So if you check all of this, if you sum this all up, it will always be 23,197 because that's the amount, that's the fixed amount that you're going to pay. Okay, nothing more, nothing less. So if you get this, if you get the interest, then of course you'll know how much will be the principal because it's just the total amount minus the interest payment. Okay, so so this one, okay, so we got the interest. Okay, we got the interest, which is the the previous balance. Okay, multiply that by the interest per period. That will be the computation of your interest. Therefore, this principal here will be how much did we pay for the month? 23,197. How much will be allocated for interest? This amount. So if you take a look at the formula, it's just, this is constant. But Phoenix natin to, we gave it a name. Amortization amount minus the interest will be your principal. Okay, let me pause here first. Okay, let's take a look at this line. Let's take a look at this line. May I have a show of hands, please, so that nobody is left out? Who among you got the 21,937? Kindly chat, please. If you got the 21,937.5. Okay. All right. Okay, good. Good. So we're okay with the 21,937. Now, how about for the principal? Before we leave this line, I want to be assure that everybody got this. And the formula is whatever the monthly amortization is. Okay, I hope you gave this a name, minus the interest payment. Again, may I know, let me just put a line here. Who among you got this? 1, 2, 5. Okay, good. Thank you. 2, 3. Who else? 4, 5. I'm still lacking one. One, two, three, four, five, six. Okay, good. All right. And then this one, class, which is just the previous month and balance minus the principal. Again, may before you answer, class, just put a line here. May I know who among you got this? Okay, good. Good, thank you. 3, 4. 2 more. Who hasn't answered yet? Ales, Sami, Sophia, Jashan, Aliana, Nix, and one more. Who hasn't answered? 1, 2, 3. 1, 2, 3, 4, 5. You're 6. Okay. All right. Thank you. Okay. So now that you have gotten these formulas will be the same in the next succeeding cells. Okay. So if I highlight this, I can just drag it down, or I can just highlight the cells, and then at the bottom right portion, you have this crosshair, and then double click it. Okay. Double click it. So mouse left. Okay. Okay. I'll ask once again. Who among you got the whole table of amortization? Okay. Thank you, Jashan. Okay, Alice. Thank you. Johan. Aliana. Okay. Good. Complete. All right. Then I said that the nature of this, okay, is that the interest will be very high at the first stage, okay, but it will keep on getting lower and lower and lower. Why is that? Because the interest is based on the principal balance, and if every month your principal balance gets reduced by the amount of principal that you paid, then your interest will keep on going down. So let's compare. Okay, let's highlight this and let's include the principal payment. Okay, and let's see if we plot this, insert, and then let's just plot a line plot here. Okay, so there you can see what's happening. This is the interest payment. This is the principal payment. If you add these two, for example, at this point, this is how much you paid. That's 21,309. If you can see the diagram, plus whatever this amount is. Okay, the total will be the 23,000 at any time. So you can see that the interest payment is going down, okay, and the principal payment is going up. Okay, but if we check, okay, so let's add all the interest payment. Alt equal to is a shortcut. If you're adding a series of numbers, make sure that there's nothing in front of that or on top of that in this case. Control Enter. Okay, and then if I copy this down, okay, you can now see the totals. The total interest payment is 5.65 million. Okay. That's the advantage, class, of having just a long period. Okay, 5.65 million. Okay, and then the total principal payment will be 2.7 because that's what we That's what we owe. Okay, so maybe let's copy this, create another one. So how did I do that? Control Z. I just highlighted this and then control, then right click to create a copy there. I now have 3 copies. Let me delete this. Okay, so do you now have a second copy? Why did I create a second copy? Because I want to compare. What if it was just, let's say, how many years? Let's first take a look at our table here. What do you want to compute? Again, property, 3,000, 3 million. And let's just make it lower. So for example, if it was only 5 years, okay, although this might be difficult for a new startup family, but let's just compare 5 years. Okay, so this will be 5 years, and the interest rate is lower. It's 6.5%. Okay, so usually if the term is shorter, the interest rate will be shorter because of interest rate risk. Okay, or so for the lending institutions, they will be charging more for those that are going to pay longer because they put themselves at a greater amount of risk. So the higher the assumed risk, the higher will be the required return. Okay, so let's make it just 5 years at 6.5%. If you compute this, so the amortization will be, it will be bigger, of course, 53,828.60. Okay, and in fact, the estimate here is that you should have a gross monthly income, maybe combined, of 150,938. Okay, because this is relatively a very high monthly amortization. The insurance is fixed, 607.5. Okay, 52,828.6. So let's compute that. Let's see. Okay, I created a new copy here. The interest is 6.5, right? Lower interest. This is just 5 years. Okay. So for this one, let me delete this. Let me also delete this. So let's apply this. Series field. Anyway, it's just 5 times 12, so that's 60. Rows 1 up to 60. Okay, so this will be up to 60. Okay, then let's compare. Okay, the interest rate. Okay, let me pause for a while and allow you to catch up. I might be going too fast. When you're done, when you have this other table here, and please chat yes so that we can continue. What we're doing is we're comparing the difference between a 30-year 30-year term loan, okay, and a 5-year term loan. And I'll leave you as an exercise to compare between 5 years, 10 years, okay, 15 years. Of course, the decision will be based on the capability of the couple or of the persons to pay the loan. 53,000 for some, but they could afford it. 52,828. Why is that? Did I put the correct? This is 6.5. Yeah, 6.5. Yeah, 52,828. Sorry, 52,828. So it's the same, right? 52,828. So, okay, okay, everybody, have you gotten up to this? Okay, are you with me on this at this time at this page? Okay, good, good. Thank you so much for your feedback. Okay, so once again, let's redo this. Okay, the interest will of course be equal to the previous month and balance multiplied by the interest rate will now be this one. It'll still be the interest per period. Only it will change because we change the value here. Okay, Control Enter. So for the first month, 14,000 is the interest. And then take note, the monthly amortization is 52,828 minus the interest rate of 14 there. So a big chunk is going to the principal. Okay. Why? The shorter the term, the lower will be the interest. The lower the interest rate will result into a lower interest payment. The lower the interest payment will lead to a higher principal, and the higher principal will of course lead to a lower month-end principal. So once again, if we click this, copy this down, click it, okay? So after 60 months, you can see that you have paid off your principal, 0. Okay, no more utang, no more borrowing. And if I add this, Alt equal to, Control Enter, okay? So the total, the total interest is 469,000. And of course here, it's 2.7. Unlike in the previous one, where the total interest is, wow, right? Total interest is 5.65 million, okay? More than twice the principal payment, okay? Of course, the one advantage of this one, quote unquote advantage, is that you have lesser monthly amortization. And in terms of, let's say, since you're a starting family, okay, it will be easier on the pocket, 23,000. Okay, so if both of you are working, then perhaps you can easily pay off the monthly amortization. The only disadvantage is that if you're going to carry this for to 30 years, then you really have a huge interest. Interest. Okay. Now, for some, what they do is they start with a longer number of period, but later on, as they earn more, they pay a greater amount, bigger amount. For example, you can pay more than 23,000. Let's say if you have extra cash, then you decided to pay, let's say 50,000. But when you do that, you go to the main office of HDMI and tell them that you're going to pay this, but the extra payment, okay, should be a reduction in the principal. Because if you don't do that, if you just pay sa mga bayad centers, then this will be considered, the amount that you paid would be considered just an ordinary amortization. So the 50,000 there will be subjected to the same interest rate, 50,000 times 0.8125. Okay. Unlike if you say, I'm going to I'm going to use the, let's say you're going to pay 50,000. So what will happen is that 50,000, they will deduct 23,000 out of that. Okay. So the 23,000 will be considered as your monthly amortization. The 27,000 will be deducted from your principal. Okay. So the 23,000 will have its normal course of interest and principal. But the balance between this one, 50,000 and 23,000, will be automatically deducted from your month-end principal. And you know what happens if you keep on decreasing your month-end principal, your interest goes down, right? Okay. So for the next one that we're going to do, okay, that will be for next week. Okay, we'd like to have a dynamic amortization model. Okay, here I think it's you. Here, class. Dynamic amortization table. What will happen is that we're going to put extra payments here. So what will happen? What will the result be if you have extra payments here? Okay, so we'll just change this next time. Okay, any questions so far? Any questions, class? So you can see what were we able to accomplish? Number one, we were able to create an amortization table. So based on the amortization table, okay, of course you have to know the amount to be financed. It will really depend on what you're borrowing. Okay. For some, but usually if the value is, let's say, a certain amount, you cannot really loan the whole amount. You have to have an equity or like a down payment for that. So what will be financed will be the balance. Okay. Then you have the interest rate, then the number of periods. The interest rate will now be you have to know usually pag ganyan class it's usually monthly. So whatever the stated interest there is you have to divide it by the number of periods, usually 12, and then you get your interest rate per period because that's what you'll be using when you compute for the interest. Okay, and then this table will tell you how to how your payment will look like every month. Okay. And what will be happening to your okay. All right. I think I'll be asking you to do an assignment. Okay. You're going to plot this. We're going to plot the interest and the principal, but this time not as a line plot, but a okay, but a bar chart. Okay, and this is to be submitted next. I'll give you 3 days for that. I'll create an assignment folder. Okay, and then you submit that. Okay, let's see. Maybe we can. Oftentimes I'll see bar chart for interest and principal payments for amortization. Let's see. Okay, just like this one. So this is the bar chart. This is I want you to replicate. Okay. So your assignment is just like this. Create this plot for the one that we okay, why am I not getting it? Here class. Here. Okay. So if you have a table like this, your principal, in this case, it started with the principal and then the interest. In our case, it started with interest and then the principal. But it's the same thing. Okay. It's the same thing. So due on Wednesday will be for you to create this type of a plot. Okay, so this is also 30 years, 360. And what do you think is the green one? The green one is your principal. As you know, even without the table, we know that this is the principal because it's increasing over time. Okay. And the yellow one will be your interest. Okay. So you notice what was done here was to add. The total remains the same all throughout. Okay. It remains the same. It's 251,717.22. Remains the same. Okay. You can see the bar, okay, has the same height, only that the the composition changes. Initially, the green one, which is the principal, has a low amount. The interest here has a high amount. Here, same thing. Okay. And what you notice here is that this is not on a monthly basis, but on a yearly basis here. Okay, by the year ton, by the year. Okay, ito. All right. So I'll give instructions, and then you're going to post it in the assignment folder. Okay. So let's skip this first. Let's now go first to a review of NPV, IRR, and MIRR basics. You're done with financial management, right? Would you kindly confirm that you're done with management? And I'm sure you were able to discuss capital budgeting, right, class? Capital budgeting in your financial management. Okay, good. How about the others? Okay. All right. So let's have a review of that, but this time our review will be based on Excel. Okay, so given these cash flows, you have two projects, Project Y and Project Z, and these are your cash flows. Take note, they are not your net profit. They're not your net profit, they are your cash flows. Okay, when you do capital budgeting, you do you look at you measure your cash flows and not your net income. Okay, so you do capital budgeting for your cash flows. So if you have an income statement, you can easily convert the profit into net profit into cash flows by adding back expenses that are non-cash. For example, depreciation. So you have a project here. The project life is 5 years, and these were the estimated cash flow. So for project Y, the initial investment is 1.2 million, and these are the these are the cash flows that are expected for the next 5 years. Now, tell me, is this project feasible? Will you invest here? And please answer why. Will you invest in Project Y? I want you to please chat to me directly, not to the others first. I want you to tell me if this project is feasible or not, based on those values. Answer, please. Okay. Thank you, Jishan. How about the others? Waiting for the others to give their answers. Okay. Unless Sami has an answer also. How about the others? I'm waiting for responses. Okay, Nick has an answer also. Okay, thank you. Aliana also. Feasible. Please cite your reason, please. Why you're saying it's feasible or not feasible. Okay, all right. Okay, so let me just, I won't point to the one answering, but let me just state some of the answers. For example, no, because inconsistent yearly amounts. Then another one, yes, because the NPV is positive. Next, cannot be determined. You have to compute for the NPV, okay? And then, yes, net cash flow is higher than the initial investment, okay? And then, because it has positive NPV. All right. So I hope that after this session, if you're asked questions like this, you should be able to correctly state your your answer and your reason. Number one, we said last time that we cannot add this. Okay. If I add this is equal to sum of all these cash flows. Okay. It's positive 680, which means that the cash inflows are greater than the cash outflows, 680,000. So one might be tempted to say that it's feasible. Okay, the one thing that we have to realize is that we cannot add these cash flows because it belongs to different time frames. That's the concept of the time value of money. Okay, so you do not add these cash flows, class. The value of 420 after 1 year will be different to its value today. Okay, 380,000 in 5 years' time will not be 380,000 now because money has cost. Okay, then we don't also answer based on that the cash flows is stable, okay, or not stable. So how do you answer, class? So just going back to what we discussed last time, I hope I didn't forget this. Okay, we actually, this one, class, right? We said that we cannot add these cash flows because it will violate the principle of the time value of money. So what should you do? We have to convert this into present values. Okay, and then once we have converted them into present values, then what we can do is we can add them already. Okay, and the result is what we call the net present value. Okay, so if we get the present value of this, let me use negative PV. The rate is 12%. Okay, so this does not have a name. Let's give this a name so that we can fix this. Let's highlight this. Then Control Shift F3. Okay, or you go to formulas. Let's create names from selection, or you go here. You go here to formulas, and then here, class. Here, create from selection. If you hover around this, here, Control Shift F3. Okay, I'm going to click this. All right, then Excel is guessing that the name that I'm going to give the cell 2 is on the left column. That's correct? Okay. So this now has a name, WACC, weighted average cost of capital. So this will be equal to negative PV. Okay. The rate is your WACC. So this either the workbook or the worksheet. Okay, it means that we used WACC already somewhere. So I'll just use the worksheet. I'm sorry, the workbook here. Okay. Tab. And then maybe not the workbook. Sorry, because we already used the name. Okay. So let's just use it for this worksheet. WACC. Okay, worksheet. Okay, so it's the name of the WACC is the name in this specific worksheet, comma, and per can okay. Wait. I should have started here. Negative PV rate is your WACC worksheet, comma, uh, and per is 0, comma. Oops, what happened here? If I click this, I don't know, comma, I just use WACC class. N per is 0, comma. There's no annuity here. You have this amount for your future value. Ignore the type, okay? And then I use the negative there, control enter, okay, there. And then copy it to the right. Okay, so these are now present values. They're now present values. And could you kindly chat, please? Can we now add those present values? These ones, can they be added? Please chat yes or no. Okay, the answer is yes. Okay, thank you. Yeah, we can add them, class, because they now belong to the same time frames. So this is equal to the sum of, let's sum them up here. Okay, so 159,856. So the net present value of project Y is positive 159. So we said that the decision rule is that if the net present value is positive here, decision rule. If the net present value is positive, then the project is acceptable. Okay. And we can use, instead of plotting out or computing for the present values of each of these items here, we can just get the net. And if you recall, we use the NPV function. NPV function, the rate is your WACC, yeah, comma, okay. The values are, remember, the value should be from after one period there. And then you have to do something about this, okay? Plus, you have to include the initial investment because the NPV function only gets the present values of future. So it starts with, in this case, year one. Okay, control enter, there. Same thing. Okay, kindly chat, please, if you were able to get that. If you need help in something. Okay, good, thank you. Thank you. All right. So I'll give you 1 minute, please, to do this time for Project Z. Okay. How about Project Z class? So yeah, they have different different initial investment and different cash flows. Okay, thank you, Nix. So Nix provided an answer. 244, sabi ni Nix, 244,638. Yeah, good. Jashan also has the same answer. Good. And Aliana also has the same answer. Good. Okay, so let's wait for the others. Alice also the same. Okay. Good. I think you got it. So I'll just use the NPV here. It's equal to NPV. Rate is your WACC, comma, and the values are these cash flows, and then plus this one. Control enter. So it's 244,638. Okay. Now, therefore, which project seems to be feasible? Which project should the company undertake? Will it be project Y or project Z? Okay, so all right. Okay, higher NPV, yeah. So the standing rule is that the higher the NPV, the better. Okay, but take note, this has a higher initial investment. So cost considerations might be important. The company might say, oh, we don't have 1.8 million. Okay, but we do have 1.2 million. So if we do this, we can borrow 600,000, etc. Those are things that have to be considered by the company. Okay, you have here a higher net present value. However, it will entail a higher amount of initial investment. Okay, so my question is, and I want you to research on this, how do you make a decision if the initial investments are not the same? Of course, if this were both 1.2 million, no brainer. Okay, so you have two different options. Let's say these are two machines. Machine A costs 1.2 million. Machine B costs 1.8 million. And let's say they have different features, so that their production output will be different. Maybe some features will be different. So let's suppose these were computed correctly or uh, uh, not correctly, but using correct assumptions. And let's say let's say, can be trusted. These figures can be trusted. So if they're the same 1.2 million, of course, obviously project Z is the same. But there's another factor coming in. 1.2, okay, versus 1.8. So what if this was 18 million? Naturally, perhaps the NPV would have been a lot higher for the 18 million or the 20 million. So is there a way, okay, to to determine which project would be more feasible based on NPV, and yet they have different initial investments? So I'd like you to research on that, okay? I will not answer that now, but maybe that should uh, maybe that will be question 2 of your assignment, aka also quiz. Okay, the plotting of the interest and the principal plus that question. Okay, so aside from NPV, what's another function that's used? What's another metric that's used, okay, in order to determine if there's I'm sorry. Okay, I'm sorry, this nalagay ko na to, dapat na-delete ko muna to. Okay, anyway, it's already there. So the profitability index. Okay, so take a look at the profitability index. So here, take a look at the formula. You have the cash flows, discounted cash flows, 1 plus K over T. So it's summing up your uh, cash flows and then divided by the initial investment. Okay, so actually this is one of the answers that I was asking you. because you're now dividing it by the initial investment. You're dividing the present values of your cash flows by your initial investments. Okay, so what will happen is that if you divide it by the initial investment, the denominator actually becomes 1. Okay, so now you have a basis for comparison. Okay, so let's go here. The present value of your inflows for project Y is just summing up all these present values, right? All those present values, and then the present value of your outflow is 1.2 million. Okay, so in other words, you were able to generate 1.3 million using 1.2 million. So the profitability index will just be the quotient of the two. The present value of cash inflows generated divided by the present value of your cash outflow. Okay, so for project Z, I didn't put it here, but I think I should copy this. Excuse me. Okay, so this is okay, negative PV. Rate is your WACC. Okay, let me just point this out so that it will not. Okay, WACC, comma, and then NPR is this one. And no PMT, the future value is this one. Okay. Control Enter. And then okay. And then the sum of the present value of our cash inflows will be 2044 and then divided by 1.8. Okay, so you notice that the profitability index for project Z still remains higher compared to project Y, but it's not that far. 1.133 as compared to 1.136. So based on the profitability index, which takes into consideration the initial investment, okay, project Z here, okay, is better. So we're not looking anymore just at the NPV. We're also considering the value, the amount of your initial investment. So which actually answers my question a while ago. Okay. All right, let me pause for a while. Any questions so far? Are we clear so far? Any clarification? So far, dun sa dalawang metrics natin, NPV and PI, Profitability Index. Okay, thank you. Now for Profitability Index, for example, this 1.133. 1.133 actually is 1.133 divided by 1. Okay, and this 1.136 is also 1.136 divided by 1. I mentioned to you about comparing them. Okay, now their denominators are now 1, which means their initial investments are both pegged at 1. So their initial investments are pegged at 1, then project Y gets the present values of cash flows at 1.133, while project Z gets 1.136. So their comparisons are now on equal footing kasi divided by 1 na lahat yung ano nila yung initial investment nila. Okay? So is that explanation clear, class? When you take a look at that ratio and consider the denominator to be 1, so divide by 1 yan, di ba? So pareho na silang denominator na 1. Pareho yung initial investment nila at 1. So you can now compare apples with apples. You're comparing apples with apples. Okay, any comment about that, class? Is that clear? Okay, good. All right. Okay, thank you. So let's go here. IRR. Another metric that's used that's used in comparing among investments, among capital budgeting investments is the internal rate of return. Okay. So let's take a look at this class. Let's compute for the IRR of project one, project Y, I mean. Okay, so what do you have here? We can just directly get the IRR of project Y. So I'm going to copy let's copy the cash flow of project Y, Control C. Okay. And then let's get the IRR. Okay, so this is equal to IRR. Okay. And then for IRR, you get everything there. You include all the cash flows. Control Enter. Okay. So the IRR of project Y is 18.23. Okay. So the question is, what will be the NPV of project Y if we were using the IRR as our discount rate? Okay, so I hope you got that question. My question is, the weighted average cost of capital is 12%, right here. And when we use this to get the NPV of project Y, it was 159,856. Same thing, we use this one to get the NPV of project Z, it's 244,638. So if we use the IRR to be the cost of capital, what will now be our NPV? So let's do that. It's equal to NPV. Okay. Our rate this time is we'll use IRR, comma, and the values are again this one, and then we add the initial investment. Okay. Tell me, class, what will be your NPV for project Y? Okay. Thank you. Thank you, Nix. Thank you, Sammy. Okay. Their answers are 0. Could you please verify that, class, if this is equal to 0? Kindly verify, please. Are you getting 0? So you have to compute for IRR first, okay, and then get the net present value based on the IRR. Okay, thank you. So Nix and Sammy and Sophia got 0. How about the others? What are you getting? Johan, same. Jashan, same. Okay. If I run this, Control Enter, then I'm getting 0. Okay, which is correct. So theoretically, the IRR, okay, is that discount rate where the net present value is equal to 0. Okay. The IRR is that discount rate where the net present value is equal to 0. Okay. And by the way, what's the decision rule for IRR? This is 18.23, 18.23%. Okay, so I said here, okay, project Y and project Z are, okay, we haven't done project Z. Let's do project Z. I'm going to copy this cash flow here, Control C, Control V, and I'm going to get its IRR. IRR values. Okay. Close, control enter. 17.39%. And once again, let's take the NPV. NPV of IRR of project Z, comma, value 1 plus the initial investment there. So what are you getting there? Okay, also a 0. Thank you. So 0 din to, class. Control enter. Okay, so let's evaluate this. The IRR of project Y is 18.23. The IRR of project Z is 17.39. Okay, so are these projects acceptable? Yes, these projects are acceptable because the decision rule for IRR is that you have to compare it with the weighted average cost of capital. The WACC is 12.6% here. Okay, it's 12.6%, and the IRR is 18.23 for project Y and 17.39 for project Z. Okay, so they're both higher than 12.6, therefore both projects are feasible. Now, however, in this case, project Y's IRR is higher than project Z. Okay, 18.23 and then 17.39. So project Y, okay, technically, since it has a higher internal rate of return, is better, is preferred over project Z. However, in this case, for NPV, project Z is better, having higher NPVs, and even in the profitability index, it's also project Z. Okay, so how do we decide? How do we decide? How do we decide? Because in this case, project Y seems to be better, okay, compared to project Z. Okay, now, when there's a conflict between NPV and IRR, the NPV will always prevail. Okay, it's because of how your IRR is computed. There are some assumptions made when you compute for IRR, making it more theoretically inferior to NPV. Okay, that's why others make use of what we call the MIRR, modified internal rate of return. And I'll explain this. What's modified internal rate of return? So let's copy this cash flow again, Control C. Okay, Control V. Okay, so the question is, how much is the MIRR? How much is the MIRR? So we use is equal to MIRR. Okay, the values are the cash flow, and then, comma, you have here two items, the finance risk and the reinvestment risk. So for MIRR, the finance risk and the reinvestment risk are the same. So we're still going to use 12.6. Okay, let me use the WACC here. Where's our WACC here? WACC, comma, WACC. So the reinvestment rate is the same as your finance rate. Okay, finance rate, reinvestment rate. For MIRR, it is the same. For IRR, your finance rate is WACC, and then your reinvestment rate is your IRR. So that makes it quite a bit confusing, but let's just compute for the MIRR. And here, it turns out that your MIRR, okay, here, 15.45%. So it's different from the IRR of 18.23. And let me do that here also. Control C. So let me compute for the MIRR. I think I can copy this. Control C, Control V. Okay. So 15.51. Okay. Now what do we notice? The IRR of project Y is greater than your project Z. But the MIRR, modified internal rate of return, it's higher for your project Z compared to your project Y. So what will happen if you compute for the NPV of project Y based on MIRR here, comma, and then here, and then close. Okay. So the net present value using the MIRR is different, of course, because the rate is different. Okay. It will be different from this one, from the initial one, because here we're using 12.6%. Okay. But if we use the modified internal rate of return, okay, and then do so for this one also, okay, you'll of course see that the NPV for the NPV, let's do this. I think we can copy this. Control C, Control V. Okay. The NPV there. The NPV using the MIRR, correct? Correct. Okay. The NPV using the MIRR will be consistent with the NPV using the weighted average cost of capital. All right. So it's time already, class. Now, I just want to recap this. So we talked about net present values, we talked about profitability index, and we talked about IRR. Okay. We said that sometimes NPV and IRR will conflict. Okay. NPV says the project is okay, IRR says the project is not okay. In cases like that, always choose the NPV. Project always choose the net present value. In fact, when we use the MIRR, okay, when we use the MIRR as our cost of capital, you notice that, okay, yeah, so this agrees with the WACC, discount rate. This one, 74.70. This is 94.89. So project C is the preferred model. Okay, so for next meeting, class, may I have just 5 minutes? Is it okay? Just to finish this because this is very easy. I don't want to keep this hanging, the payback period. Is it okay, class? May I have your permission to just continue 5 minutes? We'll just discuss this so that this worksheet is already over. Okay, but if you need to go, you may. Anyway, this is recorded. Okay, thank you. So payback period and discounted payback period. This is very easy, class. So this just makes use of your cash flows. And the question is, how long will it take to recover the 1.2 million? So what we do is we just accumulate the cash flows. And it's very easy to do that. You just sum up, okay, your cash flow here. And then you press colon. See what happens. After highlighting the initial cash flow, then press colon. What happens? We now have B93 up to B93. So we can now copy this to the right, but fix this one. I'm going to fix this one. Okay. F4, just letter B, okay? F4. Just letter B because anyway, when we copy to the right, we're not changing the row position. You don't have to fix 93. Okay, sum of B93 to B93 is still 1, 2. But if I copy this to the right, you notice now that the formula B93 to C93, here it becomes B93 to D93. So it stays with B93 and keeps on adding C, D, E, F. Okay? All right. Did you get it, class? Did you get the cumulative cash flow? Kindly chat, please. All right, good. Now we can compute for the payback period. So the payback period is between the second and the third year because that's the time when you're already able to recover your cash flow. It became positive here. So it will be equal to 2 years, right? Let me just is equal to 2 years plus a certain fraction. Okay. The question is, at the end of year 2, how much cash flow do we still need to recover? If you take a look at this, we still need to recover 300,000. And on year 3, how much are we getting? We're getting 320. So we're just going to get the proportion. So this is negative. I'm making it positive, negative 300 to make it positive, and then divide it by the divide by the divide by the amount of cash flow we're going to get on year 3. Okay, so this becomes positive 300 over 320. So we're just prorating it. Out of the total 320 we're going to get in year 3, we need only 300,000. Okay, so if we run this, enter, so that's approximately 2.9 years. Okay, so we're assuming that this amount will be generated uniformly throughout the period. Okay, so let's just do that for project Y. Now, here class here, okay, this is the discounted period, discounted payback period. What's wrong here is that we were adding the cash flows when we said we can't do that because this belong to different time frames. So what we can do is, okay, let's get again the PV. It's equal to negative PV. The rate is your WACC plus NPR is this one, comma, no PMT. Future value is this one. Okay, we're just repeating this one. Okay, and copy it to the right. Okay, and then what we cumulate is the present values. So we're justified in adding those present values because they're already present values. And we fix this. F4. Close this, Control Enter, and then we copy to the right. Okay, so the discounted payback period will be between 4th year and 5th year. We expect it to be longer. That's because we're using already present values. So they're lower. Then this will be equal to 4, okay, plus, how much do we need more? We need 50,082 out of the total 380,000. So we're just prorating it, Control Enter. So this will be around 4.1 years. So using the payback period, it will always be lower because you're using the original cash flows, which we said is inherently incorrect because we're adding cash flows from different time frames. So for this one, discounted payback, we're using the present values. Okay. Let me pause for a while and just entertain some questions. Any questions, please? Any clarifications? Thank you for giving me time to just finish this so that next meeting will already be going to the next topics. We're going to do the dynamic amortization. Okay. And we still have unequal lives here, multiple IRRs crossover. Hopefully next meeting we were able to finish that. Okay, any questions, class? Were you able to get it? May I have your confirmation if you were able to get the payback and discounted payback period? Thank you, Johan. Okay, next, thank you. And Shami also, thank you. Okay, sige. Okay. Thank you, Aliana. All right, so after this, I'm going to post our recording. And if you have any questions, please feel free to also PM me. Okay, sige. All right, with that, class, you have any questions, any clarifications?